Now let's go to the next question. A force of magnitude 7.2 Newton is now applied to P directly up a greatest line of slope on the plane. Now, what does this sentence mean? Technically, what this sentence means is that we normally had P at 30 degree on a slope where 2 Newton was already acting. Why? Because of its mass. Its mass was 0.4 kg, and because of that, we calculated 2 Newton was acting downwards. Now, a new statement relatively tells us that a force of magnitude 7.2 Newton is applied directly up a line of greatest slope of the plane. Line of greatest slope indicates on parallel to this line. So, and up indicates upwards direction, and the magnitude is 7.2 Newton. The question is telling us to, given that P starts from rest, that means its initial value of speed is 0. Find the time it takes for P to move 1 meter up the plane. So that means from here to approximately here, which is, let's consider 1 meter. So how long will it take for P to move from here to there? So for that, first we'll require, as we know, because this is a force question, there will obviously be acceleration. Why? Because F equals ma, and we also know that S equals ut plus half at square, v equals u plus at, v square equals u square plus 2s. So we have u, we can find v, or we cannot, we directly can find t using s and u, and we can find acceleration using force. So do you guys see the correlation? What we need to find is the time, right? We need to find time. And for that, we will need acceleration, we will need initial velocity, and we'll need displacement. We already have displacement 1. We already have initial velocity 0. We don't have acceleration. And for acceleration, we will require the resultant force, because resultant force is mass into acceleration. So let me erase everything right here. I hope you have understood what I'm talking about. If not, I'll explain again. Just wait a minute. Let me explain. Let me erase everything first. Yeah. So let's start again. So right now we have a new added force. We already have this system, and we need to find the time. And as you know, there is acceleration. We can use the equations of motion. We can use S equals ut plus half at square. For that, we know the displacement. The displacement is 1. We know the initial velocity is 0. We need to find the time. We don't know the acceleration. Somehow we'll have to find the acceleration, and we need to know the time as before. So how do we find acceleration? There's a basic formula. Let me write it with a different pen. F equals ma. And to find the acceleration, we need to find the force. And we won't need to find any other force. We need to find resultant force. So how do we find resultant force? So here we already have 7.2 Newton upward force, 2 Newton backward, and there is one more force which we need to think about. Can you guess the force? I hope you have guessed it. The force will be res res resistive force. Why? Because there is friction. So friction will lead to resistive force. So let me draw it correctly right here. Okay. So this is resistance force, friction. So we learned F resultant is equal to 7.2 minus 2 minus resultant force. So what is the formula for resultant force? How do you find resultant force? It will be UR, right? And we know what is coefficient of friction, which is U, which is root 3 by 3. And what is R? R, we already found out above. R is contact force, which is 0.4 into 10 cos 30, which is 4 cos 30. So now that we have FR, we can put it in the F resultant formula. First, the one thing you should do is you should not put this in the calculator. Find whatever the answer is. Let me tell you the answer. Uh, the answer for this would be root 3 upon 3 into 4 cos 30. The answer is 2. Yeah, so as you can see, the answer is 2 here. So let me write down 2. And then F resultant is equal to 2. Just kidding. F resultant will be equal to 7.2 minus 2 minus FR, which is 7.2 minus 2 minus 2 again, because this FR is 2, right? So we are getting the answer of 7.2 minus 4, which is 3.2. And then let's go to this equation. F res equals MA. So F resultant is 3.2, which will be equal to M. What is M? 0.4. Yeah, into A. So by that we can find A. So the value of A will be 8 meter per second square. And using that, we can use the equation S. Let me write it with a different color. We can write it S equals UT plus half AT square. S is 1. Why? Because they told us in the question that to move up 1 meter up the plane. So 1 is equal to, and they told us that P starts from rest. So U will be 0. So this entire thing will turn to 0. Half AT square means half into 8 into T square. Why 8? Because A is 8. And this 2 will go up, 8 will go down, and this root. Therefore, T is equal to root of 2 by 8, which is 1 by 4, which means root of 1 by 4 seconds, which is 1 upon 2, which is 0.5 seconds. So the answer is 0.5 seconds. Now we go to the next question. A particle of mass 0.3 kg. So this particle of mass 0.3 kg. Right now we discussed in the question that if a mass is there, the weight will always act downwards. The weight won't be like this. Weight won't be like this. The force due to the weight, it always act vertically downwards. So this will be 0.3 into 10, which is 3 Newton. Why? Because 0.3 kg. So 0.3 into 10, which is m into g, which is equal to weight. I hope you are clear with this. We'll go ahead. Is held by two light inextricable strings. So these strings are light and they cannot extend. What does that mean? And that means if a string could extend and if you use your hand, let me draw a better hand. If you push it down, the string may come down a little bit, but inextensible means if you push it down, then the string will remain the place it is. That means the string will not extend at all. That means the string will stay here itself. Now that we are ready with this, let us go ahead. One string is attached at an angle of 60-degree here to a horizontal ceiling. So this is a ceiling. Let me note it down right here. And the other string attached at the angle alpha to a vertical wall. So this is a vertical wall. And this is a horizontal ceiling. See diagram. The tension in the string attached to the ceiling is 4 Newton. So how do we decide which arrow will the tension be? Will it be this or this? So for that, you'll have to understand what tension is. So technically, what tension is if you have a ceiling right here, you have a pendulum. The pendulum has mass because it will try to come down. But will this ceiling let it come down? No. Will this string let it come down? No. So it will exert a force upwards. So similarly, this tension will be up and it will exert a force upwards like this. So this is tension and the value of tension is 4 Newton. Right here. The tension of Find the tension of the spring which is attached to the wall and find the value of alpha. So what we have to do is find the value of this tension here. This is tension of the ceiling. This is tension of the vertical wall. So how do we find tension of the vertical fall and how do we find alpha? Huh. The first thing you need to know is we'll have to we'll have to resolve the vectors. What do I mean by that? What I mean is, let me come a little down here. Oops. Yeah. That means I have a vertical wall right here. This is 60 degree. And from which here a 3 Newton force is acting. And right here, 4 Newton force is acting. So I will need to resolve this. Let me draw it in a better way with another pen. I'll have to resolve this green arrow into two components. One will be the horizontal component and the other will be a vertical component. And how do I do that? I know that this is 4 Newton. This arrow is 4 Newton, right? Because that is the value for tension the string holds, and that is the tension. So, and this is a triangle. It is technically just nothing but a right angle triangle here. This is 4 Newton and this is 60 degree. So I can use sine and cos to find to find my components. So this side, let me draw it with a dark blue pen. This side, this will be sine, this will be cos 60. And we know the formula, it will be 4 cos 60. Why? Let me show it to you. Because this is a 90-degree triangle, this is 4 Newton, this is 60 degree. If I want to find this x, so cos 60 will be x by 4 and it will go up 4 cos 60. So x will equal 4 cos 60, which is 4 cos 60, which is this. So now that we are sure with this, let us go ahead and find the vertical component. Try finding the vertical component similarly like your own, like this only, and then go ahead and listen to my explanation. So this will be the vertical component. Similarly to 4 cos 60, if I have a right angle triangle right here, this is 60 degree, this is 4 Newton. I want to find what is this, y. So sine 60 will equal y upon 4 because opposite upon hypotenuse, that is the hypotenuse side because it is opposite of the right angle triangle. So if this goes up, it will become 4 sine 60 is equal to y. And hence this becomes 4 sine 60. So now we have two directions cleared. We have resolved the 4 Newton tension wire. And what do I mean by that? What I mean by that is earlier we had this 60 degree, 4 Newton and 60 degree. Now we have something better. Now we have one 4 sine 60 and we have the other 4 cos 60. So let me write it on the side so that we can use it the next time we want. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Let me write it right here. 4 sine 60, 4 cos 60. And now let's talk about the this side, TW. Now, what we do not know is the value for TW and the angle also. So how can we do this? It is relatively easy. Instead of using values, we'll just use the variables, which is the alphabets, which is TW and alpha. So this is alpha. This right here formed a 90-degree. This is TW. So using alpha and TW, can we find this and y? Yes, obviously we can. We can use sine alpha. Sine alpha will be equal to x upon TW, and cos alpha will be equal to y upon TW, right? And then x will equal TW sine alpha, and y will equal TW cos alpha. So we know this also, that y is TW cos alpha and x is TW sine alpha. So let me rewrite that also. So this will be TW sine alpha and this will be TW cos alpha. And there is one more force, that is the 3 Newton weight, which is acting downwards. So I'll write it here itself, 3 Newton. Now let me combine everything. So first of all, what we have to do is all the vertical forces and all the horizontal forces that we have seen right now, we need to affix them again. What do I mean by that? I'll show you just in a second. Okay, yes. So there were a few vertical forces and there were vertical eraser. And there were a few horizontal forces. Which were the vertical forces? The vertical forces were these. Upwards was 4 sine 60 and 2 downwards were 3 Newton and TW cos alpha. And what about the horizontal forces? The horizontal forces, there were two, 4 cos 60 and TW sine alpha. So now let us resolve it. Here we can see that the system is in equilibrium. So we can equate this. 4 sine 60 will equal to 3 Newton plus TW cos alpha. What do I mean by that? The forces acting upwards will equal the forces acting downwards. This is technically equal to, if a 5 Newton force was acting upwards, then one 3 Newton force and one 2 Newton force are acting downwards, which means the same thing because this add up to give a 5. I hope you understand that. And now we'll go to the horizontal forces. 4 cos 60 will equal TW sine alpha. And now that we are here, we can rearrange this equation. 4 sine 60 will be 4 root 3 by 2 minus 3 is equal to TW cos alpha. And this is simply 4 cos 30, which is 2 equals TW sine alpha. Now what we can do is we can do TW sine alpha upon TW cos alpha is equal to, what is TW sine alpha? TW sine alpha is 2. So 2 upon, what is TW cos alpha? That will be 2 root 3. How did I get 2? 1s are 2s are 2 root 3 minus 3. So TW can cut here. Sine alpha upon cos alpha is tan alpha. So, and this tan can go there. And what do I mean by can go there is this tan can go there and become tan inverse. So tan inverse of 2 upon 2, 3 will give the value of alpha for us. And once we find alpha, which is, let me put it down in a calculator here. Tan inverse of 2 upon 2 root 3 minus 2. So the value is 53.8 degrees. So first we'll need to check if they are asking us in radians or degree. So they haven't mentioned it. So we can go ahead simply and write 53 point, what was it? 79, which is 53.8 degree. And now that we know it is 53.8, we can input the value in here or here, any of it. It does not matter. And we can find the value for TW. What I mean is, let me write here. Now from this equation, I can get 2 by sine alpha is equal to TW, right? Therefore, TW will equal 2 upon sine 53.8. And whatever the answer is, TW will be equal to 2 upon sine 53.8. Which is 2.47 Newton. Hence TW is 2.47 Newton. And we have our answers. Now that we have sine alpha upon cos alpha is 2 upon 2 root 3 minus 3, we can write sine alpha upon cos alpha as tan alpha. So tan alpha will be equal to 2 upon 2 root 3 minus 3. And then we can rearrange the equation for alpha. That will be alpha is equal to tan inverse of 2 upon 2 root 3 minus 3. Hence, alpha will equal, now if I put this in the calculator, tan inverse of 2 upon 2 root 3 minus 3. The answer is 76.94. So alpha will be 76.9 degrees. And now that we have alpha, and we also have the equation 4 cos 60 is TW sine A. We can input alpha in place of 76.9 and we'll get the value for TW. What I mean is, let's rearrange TW first. TW is 4 cos 60 upon sine alpha. And as you know, alpha is 76.9. So let me write that down. Alpha is 76.9. So if I put this in the calculator, which is 4 cos 60 upon sine 76.9. Sine 76.9. So the value which I'll get is 2.05. So that means the tension in the wall, vertical wall, is 2.05 Newton. Yeah. Now let's go to the next question. This question is a car of mass 1200 kg is traveling a straight horizontal road AB. There is a constant resistance force of magnitude 500 Newton. When the car passes point A, it has a speed of 15 meter per second and an acceleration of 0.8 meter per second. Find the power of the car engine. Now, this has a lot of points to cover. We'll go through one by one. So, first off, what we need to know is that it is on a straight horizontal road. So, when drawing the diagram, let's draw a diagram for straight horizontal road. Now that we have that here, let's label A and B. The car is of mass 12,000 kg. So let me write down 12,000 kg here. There is a constant resistance force of magnitude 500 Newton. So let's mention that also. Constant resistance force 500 Newton. Why did I put it behind? Why is the arrow behind? That is because the car is moving from A to B, right? That's why the resistance force will always be ulta, reverse. When the car passes point A, it has a speed of 15 meter per second. Now now the speed at A, U will be 15 meter per second and acceleration of 0.8 meter per second square. Okay. Find the power of the car's engine at point A. So power has a very basic formula. Power is equal to force into velocity. So now first we'll have to understand what is the force. So to derive force, we have the formula force is equal to mass into acceleration. So what is the mass of the car? 1200 into what is the acceleration? 0.8. So force will be 1200 into 0.8. If I put that in the calculator, the answer will be 960. So the force is 960 Newton. Now that we have the force, what about velocity? The velocity was already given 15 meter per second. And now, why are we using 15 meter per second? Because they have asked us to find the power of the car's engine at point A. And the velocity at A is 15 meter per second. That's why we are using velocity as 15. So now if we write the final equation, power is equal to force, which is 960, into velocity, which is 15. We'll get the answer, which is answer into 15. 960 into 15 is 14400 watts. Next question. This was a relatively easy question. It was a scoring question. The car continues to work with this power as it travels from A to B. This takes 53 seconds to travel from A to B, and the speed of the car at B is 32 meter per second. Show that the distance is 1362.6. This is a classic kinematics question, and there is nothing to worry about. If we just input the basic formulas, we'll get the answer. So here, initially the velocity was, let's see, 15 meter per second. Okay, at A. And at B, the car speed was 32 meter per second. Final speed. And the time taken for the car to travel was 53 seconds. So let's write down all the equation first and see which one will actually help us. First is V equals U plus AT. Next, V square is equal to U square plus 2AS. Next, S equals UT plus half AT square. Next is S equals VT minus half AT square. And 1, 2, 3, 4. And if we forget, we can look it up here. Which one is remaining? S equals half U plus V bracket T. S equals half U plus V bracket T. So what do we have here? Here we have U. Let me write it with a different thing first. Yeah, we have U, we have V, we have T, and what do you have to show? We have to show the distance. We need to find S. So where is U, V, T? But we will find A, so not required. U, V, We don't have t here, so we can't find s because we do not know the acceleration. Here we have u, we have v, we have t, and we'll find s. U v t s, u v t s. So this is the perfect combination. So what we can do is s equals half. U will be 15, v will be 32. What is the time? 53. So here we can put this in the calculator. Um, 15 plus 32, 53 upon 2. So here we have the answer 1245, but this is not matching. 15. What's the problem here? Let's see. The car continues to work with this power and B is 32 meter per second. The next question is, a block A of mass 80 kg is connected by a light inextensible string. This is the light inextensible string to a block B of mass 80, 40 kg. The rope joining the two blocks is taut and parallel to the greatest slope, which is inclined at 20 degree. A force of magnitude 500 Newton is inclined above the same. The block moves up the plane, and there is a resistance force of 15 Newton on B. So that is not mentioned here. We'll have to draw it here, but no resistance force on it. So this is resistance free. Find the acceleration of the blocks and the tension in the rope. So for that, first we'll have to find the resultant force on the system. What does that mean? That means consider A and B to be one object only. So this will have tension right here like this. This will have tension right here. But both tensions cancel out. So we do not include tension. So this is A plus B and mass is 120 kg. Actually, we cannot do it like that. We have to calculate it separately, then combine it together. What does that mean? This is 40 kg. That means this will be 400 Newton. Then this, due to weight, mg sine theta will become 400 sine 20. This is 800 Newton. So this will become 800 sine 20. The upward force parallel to the greatest line of slope will become 500 cos 15. And so here, according to the free body diagram, we have 500 cos 15 minus 800 sine 20 minus 400 sine 20. And do not forget the resistance force on B, which is 500 Newton. So minus 500 Newton is equal to, and have they told this is in equilibrium? Find the acceleration. So obviously not in equilibrium. This is equal to mass into acceleration. So mass will be 40 plus 80. 40 plus 80 is 120 into A. So the acceleration will be 500 cos 15 minus this, and this 120 will just go down. entire thing upon 120. So if we put this in the calculator, 500 cos 15 minus 800 sin 20 minus 400 sin 20 minus 500. So the answer is in negative here, but the only problem here is we did not show the blocks move up the plane and there is a resistance force of, yeah. So the negative answer was because the resistance force is 50 Newton, not 500. The error we did was we took 500 here, but it should be 50 Newton. So yeah, I guess after we clear that up, we'll be all right. 50, yes. And then answer divided by 120. So the acceleration is 0.188. So now that we have this, acceleration is 0.188 meter per second square. Next, the second question is find the acceleration block. This is done. And the tension in the rope. So what we did last time was we cancelled out the tensions because they were opposite each other, and because we were taking every force, they were cancelling. Now, if we take forces acting only on B, that will be, if I let me redraw B right here. So this is B, and the 400 Newton is acting downwards. Then this angle is 20 degree. So this is 400 sine 20. Then let me go with another color. This is a force of 50 Newton. And is there an upward force? Yes, of course. And what is the upward force? We did not draw it here, but we'll mention it now. The upward force is tension. So now that we have all of these forces in our hands, we can redraw the free body diagram. The free body diagram will be tension minus 400 sine 20 minus 50 is equal to ma. And what is the mass of this? 40. And acceleration 0.188. So now that we have everything what we need, we just need to replace the signs, which is tension is equal to 40 into 0.188 plus 50 plus 400 sine 20. By this, we'll get the answer for tension, which is, let us put it in a calculator and check it. 40 into 0.188 plus 50 plus 400 sine 20. So the value of tension is 190, 194.33. So now that this question is done, we will go to next. Find the time it takes for the blocks to reach a speed of 1.2 meter per second from rest. This is a classic kinematics question. We have various equations here, but we'll identify what all do we have here. So what we need to find is time. And what variables do we have? We have acceleration. Let I write it with A. We have initial velocity, which is u. We have final velocity, which is v. And what is the acceleration? 0. We calculated acceleration of only 0.188 meter per second square. What is initial velocity? Initial velocity is 0 because they have asked from rest. 0 meter per second. What is final velocity? 1.2 meter per second. And the question is find time. So you can simply use d equals u plus at. And what will v be? V will be 1.2, u will be 0, a will be 0.188, t in the bracket. Now that we simply resubstitute 0.188 equals t, and we put this in the calculator, 1.2 divided by 0.188, and we'll get the answer of 6.38, which is 6.4 seconds. So that means it will take 6.4 seconds for the block to reach a speed of 1.2 meters per second. from rest. Now that we have this question, let's move to the next question. By looking at the question itself, we can say the question is of momentum because we have written A, B, C, and then we can see collide, words like this. So let's read the question now. Three particles A, B, C of masses 0.3, 0.4, and m respectively lie in a straight line, horizontal smooth plane. That means it is a smooth horizontal plane where A, B, and C will lie. This is a basic, I don't think this will be a hard question for you, and the masses are 0.3, 0.4, and m. Kg, let me write down the units too. Kg, kg, yeah, perfect. So the distance between B and C is 2.1 meter. Now we have that also. This distance is 2.1 meter. A is projected towards B with a speed of 2 meter per second. Let's mention that in the diagram too. We should not miss anything here. After A collides with B, the speed of A is reduced to 0.6 meter per second. So let me write down U equals this. And after collision, I can mention it like V is 0.6 ms minus 1. Still moving in the same direction. Okay, so that means V is in the same direction as U. Show that the speed of V after the collision is 1.05. Now we can use a very simple formula. Initial momentum is equal to final momentum. So what is the initial momentum? The initial momentum will be 0.3 into 2. But before that, the formula for momentum is mass into velocity. So the mass is 0.3 and the velocity is 2. And what about the final momentum? We know that the speed of A is reduced to 0.6. That means A, which is 0.3 kgs, will move in 0.6 plus some velocity for B, 0.4 into which we don't know. Show that the speed of B. That means we don't know the speed of A. So now that we have this, we can do 0. We can put this on the left side, making a negative, and this can go down. I'm doing it quickly because it is easy algebra, which is equal to V. Then simply putting this in the calculator, what do we get? 0.3 into 2 minus 0.3 into 0.6, answer upon 0.4. So the answer is 1.05, which is exactly what we need because they have already told us show that the collision, after the collision, the velocity should be 1.05. So V equals 1.05. This question is done. Next, after the collision between A and B, B moves directly towards C. The particle B now collides with C. After this collision, the two particles coalesce and have a combined speed of 5 meter per second. So let me tell you what this is telling. So after A and B, right now, earlier we had the three balls, A, B, C. A went to B, then AB collided, right? Then B started moving. And as B started moving towards C, even B and C collided, and B and C stick together and started moving. B and C became a same group. They this means to stick together. So they are telling us have a combined speed of 5, find the mass m. M of what? We know that m here was written, m denotes the mass of C. So they are telling us to find the mass of C. How do we do that? We use the same formula. Initial momentum is equal to final momentum. So now what will be the initial momentum be right here? Initial momentum will be the velocity of C. So velocity will be the momentum of B. So that is mass into velocity. What is the mass of B? The mass of B we'll have to check is 0.4. And what is the velocity at which B started to move? The velocity at B started to move is 1.05. How? This is what we show that the speed of B after the collision is 1.05. That's what we found, the speed of B. So mass is 0.4, velocity is 1.05 is equal to final momentum. What is final momentum? Final momentum is mass into velocity too. So what is the mass right here? Now we found out that they coalesced. That means they stick together. So the mass will add up. For example, if you have a box, if you put two balls, so the mass of the balls in the box add up, right? Exactly like that, this will add up. So the mass will be 0.4 plus m into velocity. Velocity is 0.5 as they have a combined speed of 0.5. That means when they stick together and they hit, they started to move at 0.5 s minus 1. So now that we have this, we simply have the answer in our hand. We just need to rearrange the equation, which will be 0.5 into 1.05 upon this goes down upon 0.5 equals 0.4 plus m. Now this 0.4 will go them and become minus 0.4. And now here we have the answer. We just need to put it in our calculator. Minus 0.4 plus 0.4 into 1.05 upon 0.5. So the mass of the ball is 0.44 kg. Okay. So we are done here. The mass of the ball is 0.44 kg. Find the time it takes for the instant B and C collide until A collides with the combined particle. So now what do they mean here? We came here already. First A collided with C, A collided with B. Then A started to move, right? After A collided with B, A did not stop. A was still moving. At what speed? A was moving at 0.6 ms minus 1. And now after BC collided, this started to move at 0.5 ms minus 1. So the scenario looks something like this now. Here we have A. Let me draw a circle rather than a square. Yeah. Yeah. We have this. Right here is A and right here is B and C. BC combined. So A has started to move at 0.6 ms minus 1 and BC has started to move at 0.5 ms minus 1. Why? Because they asked her to, they told us if B and C have a combined speed of 0.5, we are using that. And they also told us that A is reduced to a speed of 0.6 after the collision. That means A will move at 0.6. Now, because this is moving faster, at some point it will touch this, right? It will, they both will be the same distance because this one is moving faster. So the question is find the time it takes from the instant when B and C collide until A collides with the combined particle. So what we need to realize first is A, B, C were in the initial positions like this. A came and hit it. So we'll go with when A goes and hits B. And this distance is 2.1 meter. Perfect. So the velocity of B after collision with A, the velocity of B after the collision with A is 1.05 ms minus 1. So what do you think? How much time will it take for B to reach C? So we can do that simply by time equals distance by speed. Distance is 2.1, speed is 1.05, so the time is 2 seconds. So that means it will take 2 seconds for B to reach C after the collision. Now, how much distance, let me denote distance with S, how much distance will A cover in 2 seconds after the collision with B, like after this point. So B has already started to move now in 2 seconds. After 2 seconds, if I write it that after 2 seconds, the scenario will be something like this. A will be here, BC have already collided, but A will also come a little bit near because even A is moving. If I want to picture it perfectly, it will look something like this. Initially, A is here, B is here, C is here. You pay very close attention, it will be all clear to you. Then A is moving at what speed initially? A is moving at a speed of 2 meter per second. Perfect. is moving at a speed of 2 meters per second. After A comes here, B starts to move at a speed of 1.05 meter per second, and A starts to move at the speed of 0.6 meter per second. And what happens after that? Let me again go to the green pen. This distance is 2.1 meters, right? This distance is 2.1 meter. Which distance? This and this. So now that we have this distance, we can tell that B will be here, C will be here. And after how much time? After 2 seconds. Why? Because we already calculated that it will take 2 seconds for B and C to collide here, right here. So after 2 seconds, we know this is after 2 seconds. But now A will not stay here, right? Because he has a velocity, A has to go somewhere ahead. That means A can be somewhere here, 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 here. Where exactly? Where exactly we do not know. Why? Because we'll have to find out. So what is the velocity of A? The velocity of A is 0.6 meter per second. And time 2 seconds. So in 2 seconds, distance is velocity into time. 0.6 into 2 will be 1.2. That means A will cover a distance of 1.2 meters in 2 seconds. So it will come somewhere here. So if we write it down in another way, that will be, if this is the entire distance, if from here to here is 2.1. That means when B and C will reach here, when B and C collide, A will be somewhere here. A. If this is 2.1, then this distance will be 1.2. This is the main idea here. So the distance remaining here will be 2.1 minus 1.2, which is 0.9 meter. So now that the distance remaining is 0.9 meter, we'll have to find out how much time is remaining. So for that, we'll have to find the distance covered by BC together, coalesced, will be velocity into time, which will be 0.5 t, and the distance covered by A will be velocity into time, which will be 0.6 t. Now, A, the total distance A will travel will obviously be 0.9 more than distance traveled by BC. That's when they'll meet. Why? Because A is 0.9 meters behind, right? So we can rearrange this equation as 0.6 t is 0.9 plus 0.5 t. So once the 5t goes there, it will become 0.1 t is equal to 0.9 and time will become 9 seconds. That means after 9 seconds, A will collide with BC. That's the question. Now, this was a tricky question. If you want, you can listen to the explanation once again. This question, once you start solving questions like this, you will have confidence in the mechanics paper that you can score well. Even though this may look a little tough to you, once you do 3 or 4 questions like this, you'll have the confidence of solving the questions on your own. So don't worry and keep practicing. 7th question. A particle P travels in a straight line. So this is a easy question regarding straight line or velocity acceleration. Starting with acceleration of P at time A and constant velocity of P at T at 1. Find the velocity of P at T equals 4. So we have to find the velocity at T equals 4, but there are 2 values here. So which do we find? Now let's see what we will have to. So we all know integration of acceleration is velocity. So let's integrate the acceleration here. So the integration of acceleration will be the integration of 0.3 t 1 by 2 dt, which will equal, which is velocity, which will equal 0.3 t raised to 1 upon 2 plus 1 upon 1 upon 2 plus 1. So this equals 0.3 t raised to 3 by 2 upon 3 by 2. 2 goes up. 3 into 2, this cuts 0.1. So the answer is 0.2 t raised to 3 by 2. So now that we have velocity, and the velocity, we should also include a plus c. What does this plus c mean? Y-intercept. And because we are drawing a velocity time graph, and what does the y-intercept represent? The velocity at time equals 0. So what will be the velocity be at time equals 0? That will starting from rest. So the velocity at time equaling 0 will be 0. So that means the graph will start something like this, whatever it is. But the graph will start from 0. So this c is eliminated because c is 0. And they have told to find the velocity at p time equals 4. So it should be 0.2 4 raised to 3 by 2. Should be 2 to 8. 8 into 0.2. The velocity is 1.6 ms minus 1. We go to the next question. It is given that there is no change in the velocity at t equals 4. Perfect. That the velocity of t at 16 is 0.3. Find the value of k. So now this equation, if we integrate it, we'll get the velocity for time between 4 to t. This equation was for 0 to 4, right? And now this will have some c-intercept. And what will be the intercept? The c-intercept will be 1.6 because the graph starts at 4 and we know the velocity of 4. If we integrate this, the velocity at 4 is 1.6. So the c will be 1.6. Now let's move ahead. They have told us to integrate a equals minus k t raised to minus 3 by 2. So integral of a dt will give us velocity, which is integral of minus k t raised to minus 3 by 2. So what will this be? Because k is a constant, we can put it outside, minus 3 by 2. Now let's work ahead. So velocity equals minus k t raised to minus 3 by 2 will become t raised to minus 1 by 2. Answer upon minus 1 by 2. So minus minus cancels out, 2 goes up, which becomes 2k t raised to minus 1 by 2. This is the equation for velocity plus c, obviously, we not to forget. And we already know c is 1.6. I'll explain why again. Because we found out that at v equals 4, the velocity is 1.6 ms minus 1. That will be somewhere here. And we are starting the graph from here at 4. And because c is, when does the graph start at? Because the graph starts at 4, we know the velocity is 1.6. So v equals 2k t minus 1 by 2 plus 1.6. And they have told us something else also. The velocity at t equals 16 is 0.3 meter per second. So when t is 16, the velocity is 0.3. So 0.3 equals 2k 16 raised to minus 1 by 2 plus 1.6. So 0.3 minus 1.6 upon 2 and then the 16 raised to minus 1 by 2 equals k. So the value for k, if we put it in the calculator, or we don't need to put it in the calculator, actually this is minus 1.3 upon 2 into 16, this will be 4, 1 by 4, so this is 1 by 4, 1s are 2s are, this will become minus 2.6. So the value of k is minus 2.6, but we'll have to add a plus sign nearby because they have written minus k. So if the value of k is 2.6, find, show that the expression. So the value of k in terms of a will be a equals 2.6 t raised to 3 by 2. And that is because the equation was a equals minus k t raised to minus 3 by 2. So it became minus 2.6 t raised to minus 3 by 2. Hence minus minus instead of positive and this became a positive.